In this tutorial you will learn how to generate contour lines using DEM files. DEM are digital elevation models which are raster data, available from different sources with different resolutions. We will use ArcGIS to process the data. We have the DEM or raster data of the Philippines, so this is technically a very large area. We will be generating contour lines from the DEM files. We have also added the shapefile of our target area. In this case we will only generate a certain portion of the raster data. After adding all the data needed, then we can proceed to clipping. Clipping is a tool used to extract the portion of raster data. However, we can proceed to contour generation even without clipping the raster, but just like what I have said that in this exercise we only need a small portion of the raster data. To clip the target area of the raster data, we can click the Windows tool at the upper portion of the window and select the Search tool, then search for clip. The result will show different clipping tool, but just select the number 2 result with Data Management tool item. Or another option is to use the Arc toolbox. In the Arc toolbox, just select the Data Management tools and then select Raster and then Raster Processing. And that's it, select the Clip tool. In the Clip tool, input the raster data. For the Output Extent option, add or drag the target area from the table of contents. Check the Use Input features for clipping geometry, for the clipping of the target area. Don't forget to select the folder location of the output to be generated. And then click OK and wait for the GIS to process the data. A notification will appear at the bottom right corner of the GIS window after processing, together with the clipped raster data. This is now the raster data recently clipped, which will be used to generate the contour lines. Now let's proceed to contour generation. We can open the tool for the processing using the Search tool located at the Windows option of the ArcGIS, and then select the Search tool to search the contour. Results will show different tools, just select the second one. Another option to open the tool on contour generation is through the Arc toolbox. In the Arc toolbox, select the Spatial Analyst tool, and then select Surface, and then finally, the contour item. In the Input Raster option, select the clipped raster. And then specify the output location. Save everything in one folder to have an organized data or files. Decide for the contour interval. In this process, let us try 10 meters. We can check and see the elevation of each contour line using attribute table. In the attribute table, we can check the contour line with the highest and lowest elevation. Just double-click the field of contour line to rearrange the sequence of the column. In this set of data, the lowest elevation is 60 meters, while the highest elevation is 1,430 meters. We can see that the contour lines generated are too close to each other. Then we can always try to reprocess and adjust the contour interval. Just repeat the process. Let us now try to regenerate contour lines and adjust the contour interval. Because 10 meters interval is too close to each contour line, we will try 50 meters, which is 5 times larger than the previous. Again, just wait for the GIS to complete the process. Now we can see that the contour lines generated from 50 meters contour interval is better than the 10 meters. Let us now label the lines to clearly visualize each elevation. Open the properties of the vector data, then select the field of contour for the label. And then label the vector data. Each contour line is now labeled with the specific elevation. I previously mentioned that it is important to organize and save the data in one single folder just like this. Take note that it is important to understand the principles of this topic first before you proceed in the data processing.